Hello friends, in our last lecture we have seen Thevenin's theorem and also we have seen how to Theveninize a given circuit. In today's lecture we are going to see Norton's theorem. The statement for this Norton's theorem is any two-terminal linear network containing sources of EMF and resistances can be replaced by an equivalent circuit consisting of constant current source in parallel with a single resistance Rn. Here the current source is given IN, that is Norton's current, and single resistance is given Rn, that is Norton's resistance. For this we are consider a circuit. We are considering the same circuit as we have seen in case of Thevenin's theorem. The same circuit. Source, EMF source, E, resistances R1, R2 and load resistance RL, terminal A and B, terminal A and C and D. The current I is flowing through resistance R1. The current IL is flowing through resistance RL. Therefore the current flowing through R2 will be I minus IL. Okay. And here the Norton's equivalent circuit as made by the statement. As per the statement, any circuit can be replaced by constant current source in parallel with single resistance. Constant current source IN in parallel with single resistance. This is the Norton's equivalent circuit. For this we have to first find out the current IL in the given circuit. And we have seen आपण मागच्या वेळेला जे बघितलं थेवेनिन सर्किटमध्ये, थेवेनिन्स थेरममध्ये, तर थेवेनिन्स थेरममध्ये सुद्धा आपण हेच सर्किट वापरलेले आहे, आणि त्यावरून आपण IL फाइंड आउट केलेला आहे. तर आपण डायरेक्टली आता या ठिकाणी घेऊ द करंट किंवा लोड करंट IL. Load current IL, and that load current IL is, we have seen in our last lecture how to calculate the load current IL. ज्यांना माहिती नसेल त्यांनी मागचं लेक्चर बघा, थेवेनिन्स थेरमचं, त्याच्यामध्ये IL कसा काढलेला आहे ते सांगितलेलं आहे. आपण आता ते या ठिकाणी डायरेक्टली घेऊ. IL इक्वल टू ER2 अपॉन R1 प्लस R2 अपॉन RL प्लस R1 R2 अपॉन R1 प्लस R2. हे आपण डायरेक्टली मागच्या वेळेला कॅल्क्युलेट केलेलं, आपण या ठिकाणी आता डायरेक्टली घेतो. अँड ऑल्सो द पोटेन्शियल डिफरन्स बिटवीन द टर्मिनल्स A अँड B. जे टर्मिनल्स या ठिकाणी A अँड B दिलेलं आहे त्याचं पोटेन्शियल, दॅट इज ऑल्सो VAB, दॅट इज पोटेन्शियल अक्रॉस RL, that is potential at terminals A and B, is AB equal to ER2 upon R1 plus R2 into RL upon RL plus R1 R2 upon R1 plus R2. हे पण मागच्या वेळेला काढलेलं आहे. मागच्या लेक्चरमध्ये आपण हे पूर्णपणे कॅल्क्युलेट केलेलं आहे. चला आपण म्हणू इक्वेशन नंबर 1, याला म्हणू इक्वेशन नंबर 2. नाउ वी हॅव these two equations, that is the current flowing through load resistance RL, that is IL, and the voltage across this load resistance RL, that is VAB. This is the voltage across load resistance RL. Now we have to find out the IN in the Norton's equivalent circuit, IN. Now to find out the current IN, just consider, for this there are some steps. For this, remove the load resistance and short this circuit. Remove this load resistance and short the circuit, and the current flowing through that short will be the short current, which is represented by IN, that is Norton's current. Now for this, let us consider this circuit, remove this load resistance RL and short this circuit. Now we draw this circuit here. We have the voltage source here the resistance R1, here the resistance R2, and we remove. This is point C, this is point D, this is R1, this is R2, and this is E, and this is the point A and point B. And we have to remove this RL. remove केला. Now short this circuit. याला connect करून टाकू. Short this circuit. The current flowing through this short represented by IN. Now we have to find out the value of this IN. For this, now we have seen that we know that when the short is connected, it means that there is no resistance. Therefore, all the current which is flowing through R1 will not flow through R2 but will flow through this short. It means that this R2 will be short here. All the current I will flow through this terminal A and B. Therefore, the current circuit, that is IN, will be equal to here I, which is equal to, therefore IN can be expressed as voltage upon resistance, that is voltage is here E upon resistance. Now what is the resistance of this circuit? Only R1, because no current is flowing through resistance R2. Therefore the resistance is R1. This is equation number 3. Now this is the IN current. This is the IN current, equation number 3. Now we have to find out the equivalent resistance RN. Equivalent resistance. Now for this, to find out the equivalent resistance RN, as we have seen in Thevenin's theorem, same procedure we have to adopt here. Remove the battery and replace that battery with its internal resistance. Now here the internal resistance is not given. It means that the internal resistance of this battery is 0. Therefore, remove the battery in this circuit. Remove the battery, that is we have taken battery is removed and resistance is 0. Therefore, this is resistance is R1. Resistance is R1. This is resistance R2. This is point C. This is point D. This is R1. This is R2. This is point A and B. This is point A and B. Now here the R1 and R2 are parallel to each other. R1 इथं जोडणं काय किंवा इथं जोडणं काय, they will be parallel to each other. They are parallel to each other. Therefore, the R equivalent, that is the equivalent resistance of this circuit, will be obviously R1 R2 upon R1 plus R2. R1 R2 upon R1 plus R2. Therefore, this R equivalent is called the RN, that is Norton's resistance, which is R1 R2 upon R1 plus R2. This is equation number 4. That now we have all those value RN and IN. Now in this circuit, replace in this circuit now in Norton's equivalent circuit, we have the Norton's equivalent circuit. Now here